right, twin for y'all's first test. This ought to be fun. All right, so if we're talking about number one, don't be the kid who doesn't know what domain is. Domain is values of x where the function is drawn. So this function starts being drawn really close to negative 11. It's not negative 11 because there's a hole. And then I start moving to the right. I see a solid dot at negative 2 and a closed dot. These two are fine because x was drawn at negative 2. And I follow this downhill line all the way until x is about 2 and there's another hole. All right, now I'm going to jump to the other side of 2. And I'm going to go all the way up, x is 6, still a solid dot, keep moving right till I hit 11. Bracket on the 11 because that was solid. So there's domain. On the range, we're talking about the values of y, where drawn. So we start drawing really close to negative 6. We got to use parentheses because there's nothing there. And we rise on either side of this v to a y value of 2. Now there's nothing here where y is 2, but we have all this where y is 2. So we get to be that 2. Y is defined at 2. And then we make a vertical jump. There is nothing between a y value of 2 and 7. Absolutely nothing. And this is just a y value of 7. That's all it is. A little interesting thing about this, because you guys have been doing some Milbrath-Math. On Milbrath-Math, it would say 7, 7. That's what it would say. That's just the way the software was programmed. Don't ask me why. I don't know. All right, intervals where the graph is increasing. That means that we have what's called uphill slope or positive slope. All right. That looks to me like it's this piece right here. And these always use parentheses, but the x value is about 2 until the x value is close to 6. So from close to 2 until you get close to 6. Decreasing is going to be negative slope. And there's only one interval where I see that happening. That's going to be that guy right there. And that starts at an x value close to negative 2, and it keeps moving right until it hits an x value of positive 2, or close to it. So close to negative 2, close to positive 2. Now we have this whole idea of positivity. Positivity. I don't know why you guys struggle so much with basic definitions, but it means above x-axis. That's what it means, above the x-axis. So let me clear off my highlighters here, and let's see what we have. We got this segment right here, all the way until we get close to negative 1, and then the other side of 5 on. So we've got this piece here, which goes from negative 11 to 2, and x is defined at negative 2, and x stays defined until you get close to negative 1. So that's kind of weird. It's probably be multiple select. We'll see what it looks like. So negative 11 all the way until we get to negative 1. And then we have this right piece over here that starts about 5 and continues until x hits 11. Intervals where we are below negative, which means below x-axis. All right. I just kind of see that V. The V's are usually easier for kids to recognize. They're also usually easier for kids to write, although this has 2 parts. You see, there's nothing at 2. There's absolutely nothing at 2. So that makes it a little bit harder, but it starts being below the x-axis around negative 1. It continues until you hit 2, but there's nothing at 2, so I can't include it. And then it continues from 2 to 5. X-intercepts, an alarming number of you guys missed this on the retake even after I gave you all the answers. Blows my mind. Like, I don't get it. You are 16 years old and you can't tell me what an X-intercept is. There's one there and there's one there. 16 years old, can't tell me an X-intercept. So one at -1, 0, and there's another one at 5, 0. I just don't believe that that's a skill that people can't grasp. Y-intercept is right there. It crosses the y-axis. That's at 0, -2. We're talking about the order pair. Average rate of change over the interval from -3 to 0. So at -3, I would be right here on the graph. All right. And at 0, I would be right there on the graph because I'm talking about x values here. I'm talking about x values. And so I went to those x values and put a point on the graph. And now I'm going to connect them with a line. And I fell from 7 to -2. So I fell 9 units. I did. I fell 9 units. It's a negative number. And I ran, if you just look over here at the interval, 3. So this reduces down to -3. Then we have the F notation. I know so many of you guys are just not understanding F notation. This is asking for the output, which is Y, when the input, which is X, is -2. That's what it's asking for. So you actually have two choices here. Oh, I can't get rid of my line. It's there. When X is -2, I could be that guy right there or that guy right there. That is a hole in the graph. There is nothing in it. There's nothing there. All right, so I've got to be this solid dot, which is 7. It's not that y'all can't learn, it's that you don't want to learn. Anyways, moving forward, this obviously isn't numbered right. This would actually be number 11. I made this slide and then I went back and modified the quiz. But anyways, that'd be number 11. The graph of y equals negative absolute value of x minus 3 plus 4 is reflected across the x-axis. What is the equation of the reflected graph? So there's two ways of doing this. One is you can memorize the rule. The new function is going to be the negativity of the old function. That's the rule, all right? So if I did that, and we'll just call this new function g of x, it would be negative absolute values of x minus 3 plus 4, which is going to be positive absolute value of x minus 3 minus 4, because of that old thing called the distributive property. And I've taught for a long time. Most kids won't memorize. And it's a will not. It's not that they can't. They will not memorize. So the other big way of doing this is to simply graph. Right? Or graph the original and the reflection. And if you can do that, you'd understand why the rule works the way it does. So if I graph the original, oops, wrong button. Maybe I'll get started here in a second. There we go. I graph the original. I have a right 3, an up 4, And that negative out there is a vertical reflection. So right 3, up 4, there's my vertex, and I'm supposed to fall 1 and run 1. Again, that's the original dude, all right? If I reflect that, I would not be 4 above, I would be 4 below, and I wouldn't open down, I'd open up. So what I still see is I see a right 3, I see a down 4, and I have an initial slope, which is your A value, of 1. So I can say, okay, cool. It's x minus 3 minus 4. And I have this understood 1 there. Again, that is understood. You got to understand the understood, kids. It's the same thing. I think most kids would have success with graphing if they could graph. And you're supposed to know how to graph. This would be number 12. Over what interval is the graph of y equals -2 plus the absolute value of x plus 6 decreasing? So let me put this in a more standard order. It's the absolute value of x plus 6 minus 2. Then I'm just going to look at it. We have to go left 6. We have to go down 2. Put me about right there. And the slope is to rise 1 and run 1. And decreasing means downhill slope. So this is the piece right here that's decreasing. It's decreasing as long as your x value is less than -6. And it actually wants an interval, but that's the idea. The x value is less than -6, almost put equality. Or as an interval, I'm thinking about being -6, -7, -8, -9, and so forth, -infinity all the way up to -6. There's going to be a lot of kids that miss that question. A lot of kids. Identify the transformations of the parent function f of x is absolute value of x that give g of x is -3 minus 2 times 3 times x plus 3, and then close the absolute value bars. So again, I'm going to put that in a more standard order. A lot of you will not do that. You just won't because, by God, you have to pick up a pencil. I put it like this because I can line it up with AFs of B times X minus H plus K. So there's A, there's B, there's H, there's K. All right? Now, we're supposed to talk about Bach first. So I know that B is, and the order is Bach. So we're supposed to talk about B first. B is 3. It's inside. It's opposite of what you think. So it's opposite. We're not making this thing 3 times as wide. We're making it 1/3 as wide. This is a horizontal compression. I'm not sure how I have this worded. I would either word this as maybe 1/3 the width. That's probably how I would say it, because it's opposite. I may have to go back and look at how I wrote that test question. Then we're supposed to do H, and H is 3. We do opposite again. It is inside, so it's opposite. We actually shifted left 3. Now we're supposed to look at the letter A. A is -2. So we definitely have what's called a vertical reflection. That comes from the negativity. And we have a vertical stretch. Factor equal to 2. And the last thing we're supposed to look at is the letter K. And K is -3. And that's outside things we trust. This is a vertical shift down 3. This one won't go so hot either. This one will not go hot at all. And that's the thing, like, you've had the practice. I know it's not going to go well. That doesn't mean I don't do it. In the state of Tennessee, 75% of all students are deficient. And the only way you get over being deficient is you just keep hitting kids with things that they just don't want to do. They have to practice it. They have to fail at it. They have to try to succeed at it. It's the only way you get better. So I'm going to graph this thing. You know, I know that this is just fancy for y. Y equals -6. That's a horizontal line. Y equals 4 minus x. That's a line that crosses the y-axis at 4. And then it has negative slope. Falls one and runs one. It looks something like that. Then I have y equals 3. And by the way, this -6 is an O. Never mind. I should just use different colors. Y equals 3 is up there. This is not a hard piecewise function. It's not. So y equals -6 is drawn from -1 to 2. Notice the closed dot at -1. And it's -6. Nice closed dot. And it's drawn all the way till x is 2. And that'll be open. This one I might do a table. On your test, this is not multiple choice. This is you draw. I need to be clear on that. You are drawing this thing. I'm going to feed it values of 2 and 4. If I feed it a 2, it returns a 2. If I feed it a 4, it returns a 0. Solid dots in both places. So when x is 2, y is 2. And when x is 4, y is 0. That does not look right, because I'm not plotting points correctly. When x is 2, y is 2, and when x is 4, y is 0. Nice little slanted piece there. And then we have 3. We're 3 for every x value greater than 4. And symbolism says open hole. And we just keep going to the right forever, because there's no boundary on when it stops. It's a simple little piecewise function. It is. Now, last year's group was pretty weak. I don't remember more than 1 in 10 of them getting it right. This year, I'm hoping for 4 out of 10, maybe 5 out of 10. Graph the equation for the piecewise function, write the equation for the piecewise function shown. So this guy right here, it looks to me like if I extended it out, it would probably be x squared. I don't know why I wrote that as a subscript, x squared. This is literally y equals 5. And if I extend this to the origin, and I use mx plus b, I have a b value of 0, and I have a slope of rise 1, run 2, so 1/2 x. It's not that hard to write equations. Now, the first equation that's mentioned should start on the left, and it's x squared. The next equation is going to be this little line right here. It's just 5. And the last equation is 1/2 x. Anyways, moving on to domain, this piece is drawn so long as x is less than 0. And I don't see an open dot. So it's x is less than or equal to 0. This piece is drawn from x values of 0 until 2. And they're both open, so less than symbols. And this piece takes over at 2. And it's drawn forever to the right, greater than equal, because it's closed. It's closed. There you go. There's that guy. Moving forward. Which of the following sequences are arithmetic? Arithmetic means we add or subtract. So what I'm going to do is I'm going to look for what's called a common difference. From 1 to -5, you lose 6. From -5 to -3, you lose 3. But you add or subtract a common difference. You know what's sad is kids are going to miss this. It is so sad, but it's going to happen. It is not 1 because the difference is not the same. From 9 to negative 10, you lose 19, and you lose 19 again, so definitely choice 2. This one's got a fraction, but I know that a quarter plus a quarter is a half, and I know that a half plus a quarter is 3/4. So I'm adding the same thing, choice 3. The next one's kind of funny. It's got some fractions. It's 1, 5/6, 2/3, and a half. You know, most of y'all aren't going to do too hot on that because it's fractions. By the way, you'll have a calculator. If you do 1 minus 5/6 to see what the difference is, because 5/6 is smaller, you get that there's a difference of a sixth. Okay, if we do 5/6 take away 2/3, then we go to math, answer frac, the difference is still 1/6. If we do 2/3 take away a half, guess what? Guess, just guess. Guess what it is? It's a sixth. So we have the same common difference of a sixth, and that is arithmetic. Even though you were subtracting, still arithmetic. 15, write the explicit form of the arithmetic sequence 2, -7, -16, -25. So the explicit form is that the nth term is the first term plus n minus 1 times that common difference. Sometimes I put the difference in the front, sometimes back. From 2 to -7, the difference is 9. It's actually negative. We're losing 9 units. And it looks like that pattern holds. From -7 to -16, we're also losing 9, and we're losing 9 again. So I'm just going to put that there where the difference is, and that goes there where the first term is. On the quiz I gave y'all, no more than 2/3 of you got this right, which is better than some years. It's not where I want it. In a perfect world, 90% plus of my students would get it. Actually, in a perfect world, you'd all get it. But it's not a perfect world. We distribute the -9, we get -9n plus 9. And then we combine like terms. We have a -9n plus 11. I'm just going to make sure what I wrote works. Okay. And that's worth talking about because it's a good standardized test skill. I'm going to check to see if this works. The first term should be 2. So let's plug in 1. It is. Probably works. All right. Write the first 4 terms of the sequence defined by this guy. The retake quiz, I probably still had about 10 individuals who missed this question, even with this just sitting there. That's the form for a recursive sequence. So the first term has got to be 12. And this is saying add 3. So if I take 12 and I add 3, I get 15. If I add 3 again, I get 18. How many terms do I want? 4. If I add 3 again, I get 21 because I'm adding 3 as I move right. This one will be a little harder than the one I gave on the quiz. It says find the sum of the arithmetic sequence. It goes from 33 to 22, or 33 all the way to -99. There's 2 ways of doing this. It's not too hard to do. I'm going to do the formula because I teach formulas. I'm supposed to teach higher level concepts other than just writing things out. But the sum of n things is going to be n over 2 First plus last. And the first term is given, so is the last term. That's going to be negative 66. You can push buttons if you want. But the real question is, what is n? Like, it doesn't say, and the dot dot dots means we continue. So what is n? There's lots of ways of doing this. And again, I teach formulas, and formulas are quicker for me than they are to write things out. That also happens to be me. But I know that the nth term is the first term plus d times n minus 1. And you see that guy right there? It's negative 99. It's got to be the first term of 33 plus the difference, which is to lose 11 times n minus 1. So negative 99 equals 33 minus 11n plus 11 because of the distributive property. And if I take 33 away from negative 99, I get negative 66. And if I take another 11 away, I get negative 55. Something seems wrong with this. Oh, because I'm doing my math wrong. That's what's wrong with it. Supposed to take that away. It wasn't. That's negative 132. Take away another 11 is negative what? 143? Negative 132, yeah. Negative 143 is negative 11n. And then I divide by my negative 11. That's 13. Yeah. There's 13 terms. And this is going to be a hard pill for a lot of you to swallow, just doing it this way. It really is. And then I can push buttons on a calculator. I haven't quite woke up yet. And let's not make any mistakes in the video. Yeah, 13 over 2, if you don't know it, 6.5. And then we're supposed to multiply that by negative 66. There we go, it's negative 429. Now, I did this way because if I was doing this by myself, it'd be a lot quicker. On this sequence, you'd really be kind of stupid if you didn't write it out. Sum, so you're doing 33 plus 22 plus 11 plus 0 plus negative 11 plus the next term's negative 22, the next term's negative 33, the next term's negative 44, the next term's negative 55, the next term's negative 66, the next term's negative 77, the next term's negative 88, and the last term's negative 99. And then push buttons. All right? That always works, kids. All right, 18. In a theater, there are 48 chairs in the first row. Each row has 4 more chairs than the previous row. So they just gave us the difference. And there are 22 rows. They just gave us n. And this guy right here is the first term. How many chairs are there in the theater? So that's saying count them all or add them all up. So again, that's the sum of n things, and it's n over 2 first plus last. There are 22 rows, so n is 22. The first row has 48, and I need to know the last. The last row that I need to know. So I'm going to do again this formula right here. A sub n is the first term plus n minus 1 times d. And 22 rows, the a sub 22. The first row has 48. I am at the 22nd row, so n is 22, and the difference was 4. "21 times 4 is, I hope, 84. If I add 48 and 84 together, I should get 132. You can push buttons and check me if you want. Entirely up to you. 22 over 2 is going to be 11. 48 and 132 should be 180. So it's going to be 1,800 plus another 180. It's going to be 1,980 seats or chairs. It's a big theater, isn't it? It's a huge theater. It's gigantic. All right, using a graph to solve. So we're going to graph each part. I'm going to start with doing this one. I'm supposed to go up 3. Oops, I put my point too soon. I'm supposed to go up 3 and right 1, and my slope is 1/2. Rise 1, run 2. You have to go both ways. Now the other dude is absolute value. 0, 0, 1, 1, negative 1, negative 1. Positive slope for all of eternity of 1. Oh, I remember this one. This one's got another answer. It's going to be up here. This is that one that I should have used a bigger grid on. Okay, so let me pause this real quick and get a bigger grid. Now, by the time you actually do this piece of paper, you won't have seen this mistake. So if you're wondering what's going on there, I fixed something. So anyways, let me start over. I've got to go right 1 and up 3. And the slope is 1/2. And I get to do that forever, because that's how this be working. Oh, I messed up there. Those dots are important. If you just try to draw a straight line, you'll miss it. And then I have absolute value of x, which again has the points 0, 0, 1, 1, and negative 1, positive 1. And I'm just going to do lots of points because sooner or later I'll have my intersection. And there it was. One of them, anyways. And there's the other one. So I have these nice clean intersections here. I changed color, did I not? Here and here. So if you just look, that says x is 5. And if you look, that says x is -7. 2 solutions. Easy peasy, Japanesey. Moving on to 20. Solve the system of equations algebraically. Man, I picked an easy one. I'm going to push elimination method. That's just what I'm going to do. I'm going to push elimination because I like elimination. I really do. Elimination is probably my favorite way to solve systems of equations. So I'm going to multiply the bottom equation by -2, and that'll give me -2x plus 2y equals -32. And we'll just throw the other equation on top of it, and we'll add down. The idea was to multiply one or both equations so that you have what's called an additive inverse of one of the variables. Funny word there, additive inverse. 6 and 2 makes 8. 12 and -32 makes -20. Really, fractions. I guess so. Well, good for me. We're going to divide out that 8, and we'll have -20 over 8, which is -10/4, which is -5/2. And now that we have a y value, we can just plug it in. It doesn't really matter where you plug it in. I'm actually going to put it in the first equation because there won't be a fraction anymore. Like that fraction will disappear some. So 2x plus 6 times -5/2 is 12. 6 over 2 is 3, so 2x minus 15 is 12. That's why I put it there. It wouldn't be a fraction. I'll end up with a fractional answer, but not till the end. 2x is 27, and x is 27/2. Interesting. I just really surprised that came out to be a fraction. but it did. So anyways, you'll be giving your answers here as ordered pairs. 27 halves and -5 halves is your solution. There you go. All right, 20 is use technology to solve an equation. So the equation here is -3 absolute values of x plus 2 plus 3. And this is pretty simple to do. We'll place this in y1, right left-hand side in y1, right-hand side in y2. Found your answer nearest 10 thousandths. That's the fourth decimal. And let's see, we're going to go to good old y equals. And there we're going to put -3 math num abs x plus 2 arrow out plus 3 into y1. Here we're going to put a quarter. You can go to math num, hit the up arrow, you'll find n over d. Or you can just type it as I wrote it. You can write parentheses around 1/4. And then we have x squared minus 3. If you don't have a TI-84, the librarian has them. She does. So check them out to you. And then we do a zoom 6. There's your absolute value equation. And here comes your quadratic. And there are two answers of this thing. There are two of them. Now, what I've done so far, because some of you need to be writing so you remember things, step 1 was to place left-hand side into y1. Step 2, place the right-hand side into y2. Step 3 was a zoom 6. And step 4 is going to be hit second trace intersect. Get close. And then enter 3 times. And you'll have to repeat that process because there's 2 answers. All right, so second trace 5 for intersect. I'm already close to an answer. Enter, enter, enter. Oh, it was at 0, -3. So this one was legit. X equals 0. That's pretty obvious just by looking at the graph, isn't it? The next one won't be quite as nice. You got to go through the process again. Second trace 5. I'm just pressing that left cursor for a while. And then I got close. Enter, enter, enter. And it's -3.1652. -3.1652. See if my mind can remember that. -3.1652. And there's your 2 solutions. It said 10 thousandths, by the way. 10th, 100th, 1000th, 10,000th. 2 to go. Man, I've been at this all morning. Graph this guy. This was bad on the last quiz. I know that 36 and 72 are both divisible by 36. If I factor 36 from 36x, there's x. If I factor it from 72, there's a 2. You know, just push buttons, kids. Some of y'all. God love you. Just push buttons. 2. See? Still under a square root symbol. The 5 on the outside. Square root of 36, if you don't know it, it's 6. 6 square roots of x minus 2, add 5. I'm not asking you to graph mom, I'm just asking you to graph this. So I'm supposed to go right 2 and up 5. And then I have a slope of 6. 1, 2, 3, 4, 5, 6, and run 1. Put me about right there. And then I just draw that arm. That's what it looks like. All right, graph that one. X squared minus 7x plus 12. And you're doing this old school by hand. So I'll have some information here that I'll want to know. Your vertex, the x coordinate of the vertex is at opposite b over twice a. A is 1. is -7 and C is 12. So this one's going to be kind of funny. Opposite of a -7 is +7 over twice a 1. As much as I hate decimals, there you go, 3.5. Your y-coordinate of the vertex is found by taking that number and plugging it in. Let's see here. So let me use a storage feature. You don't have to use a storage feature. I just like it. Probably haven't talked about it yet. But I took 3.5, I hit the store button, chose X. Now I can type in the original equation. And I got -0.25. Okay. So I go right 3.5 units. And I go down just a touch. Just a little bit. I'm going to find my zeros. I'm going to take x squared minus 7x plus 12. I'm going to set it equal to 0. I'm going to factor. Factors of 12 are going to be 3 and 4, 2 and 6. But I like 3 and 4 because 3 and 4 will give me a 7. And if I make them both negative, I'll add to -7. So I have zeros. Remember, zero product property. X minus 3 is 0. X minus 4 is 0. X is going to be 3 or X is going to be 4. I have a 0 there and a 0 there. Ta-da! Graph to parabola. And that is the twin for your next test. Full explanation done within one class period. You can do test.